Hello and welcome to another episode of Geography Made Easy. In these videos, we try to make difficult geographical topics easy. Today, we will be continuing with the Earth's interior with special reference to seismology. So, when I was compiling this particular topic, I realized a few things and I would like to share this before we start this particular video. That is, a lot of the understanding about the interior of the earth is changing, and not a lot of geographers are very well equipped to actually talk about the interior of the earth. Current research can be acquired about the earth's interior, and this is mostly done by people who study geology. So, seismology, that is the study of earthquakes and the interior of the earth, is a domain which is not very much within or not very strongly related to the discipline of geography, because mostly we deal with the surface of the earth. As a person who teaches and studies geography, I will always feel that I am not the best person here to explain everything about the Earth's interior, but I will, of course, give you a brief understanding about the Earth's interior and the evidences we get through seismology. Because this topic is very complicated, I will try and make it as simple as possible. So, the first thing that comes into our mind is about the discipline of seismology, or what is the term here? What does it mean? What do you understand by the word seismology? So, seismology is a branch of science which concerns itself with study of earthquakes and their related activities. So, whenever we are studying earthquakes or tremors inside the earth, or on the surface of the earth, this is studied within the discipline of seismology, which has, of course, overlaps with geology and more like complex physical sciences and earth sciences within that domain. And the scientists who study seismology, earthquakes, and the related phenomena, they are called seismologists. So, seismology helps us or has helped us to understand how the Earth's interior is. Because we told in the previous video that we do not have direct evidence to tell us about the interior of the Earth. So, we have to rely on the indirect evidences, and some of them we discussed in details in the previous video. So, here I will talk about how seismology has actually established our belief about the layered interior of the earth. So, we have basically two theories which talk about the earth's interior or how earthquakes originate. So, the first particular theory, it is called the elastic rebound theory. So, elastic rebound theory talks about the Earth's rock surfaces, and these rock surfaces are elastic in nature. So, they are not completely brittle, but they have some amount of elasticity. So, just like a rubber band or just like any hard body surface, which which will break after a certain point, and certain bodies have certain different elasticities. And we have a very interesting video on YouTube and Instagram where a lot of pressure is put on different objects, and it is seen that how it breaks. So a water bottle will bend and break in a different form than a sponge. So but it will break, but the elastic rebound theory will talk, or the elasticity or the elastic reboundness of a sponge will be much higher than, say, a water bottle or a plastic surface. So different types of rocks, they also have within themselves this particular way by which it can absorb or bend, and it will of course bend till the time it breaks. So in diagram number 3 we see a fault line getting formed. So the elastic rebound theory actually talks about this fault line. So this, if this is the earth's surface, this is the rock, it is going to bend till the moment it crosses the threshold, and then it will break. And when it breaks and a fault is getting formed, we see that tremors or earthquake tremors are formed along the fault. So we see that the earth starts shaking, or the earthquake waves they get formed. So this explains one of the reasons why earthquakes take place. The next particular reason why earthquakes takes place is volcanic activities, and this is one of the most accepted theories, and we have more theories which address the earthquake theories. Let's explain this volcanic activity theory, which is quite a simple theory. So we know that a volcano is when we have on the surface a particular like the pathway through which the magma from the interior part of the earth, that is the asthenosphere, it can flow out. And this is how we usually know that a volcano will look, with a vent at the center. So the magma, this is my magma, it will well out from the vent. So this is called the vent, and it will spill out and it will form the mountains. So this happens through layers, and there are many different kinds of volcanoes, and there are different reasons by which volcanoes are formed. So when this volcanic eruption takes place, and especially when it's a violent eruption, we see that tremors get generated, and we see that earthquakes takes place. And volcanic activity is also related to plate movements. So we know that uh, the surface of the earth is divided into not, it's not one rigid body, rather it is broken up into uh, flat surfaces called plates. So we know that the crust is broken up into these plates. We have the oceanic plate, we have the continental plate, and we have plates which have both the oceanic crust and the continental crust. In certain parts, we see that there is subduction, or one plate will move below the other plate. And so when we have this, so say this is plate number 1 and this is my plate number 2. So this plate is heavier, so it is moving down, and this plate is lighter, and usually this part gets melted and we see volcanoes getting formed here. So the Pacific Ring of Fire is because of this. So this is explained in details in plate tectonics chapter. So we see that volcanoes get formed in the along the subduction zones. So here we see that there is a tendency, whenever the plate movement takes place, we see that there is a tendency of earthquakes getting formed. And we can give a good example here from the Himalayas, where we know that the Sangpo Suture zone is where the plates are, the Indian plate is below the Asian plate, and it has sunk, and it is along the suture zone where the Brahmaputra or the Sangpo river actually is flowing along this line of weakness. And whenever there are these earthquakes which are taking place in the Himalayan regions, which is a highly tectonically active area, we know that there is subduction or movement which is taking place, which results in this particular tremor which takes place. So um, the seismic evidences or the earthquake waves, they tell us a lot about the Earth's interior, because here we have to understand about the nature of the seismic waves. So there are basically two types of seismic waves. One is the body waves and the surface waves. For our understanding, when we have to understand the interior of the earth, we will be concentrating in on the body waves. The surface waves, we will just read about them, but the evidence is gathered from the body waves. So the two types, or the major two types of body waves which are there, they are the primary waves or the P waves and the secondary waves or the S waves. And I've put a video to show how the movement of particles along the P waves and the S waves take place. So in case of P waves, we can see that uh, there is the particle movement is in this manner. So it is like compression and tension. So in this way, the movement of the waves take place. On the other hand, the S waves, we see it is in this fashion. It is in the normal fashion in which light waves and sound waves, they travel. So the particle movement in case of S waves is in the vertical direction, whereas in case of P waves, so I'll just write this here, particle motion. In case of the P waves, it is in this direction, in the horizontal direction. And it is important because we need to understand how the particle movement takes place. So the P wave or the primary wave, they travel through solid rock and fluids or water or liquid. So they are traveling through both solid and liquid. Whereas the S waves or the secondary waves, they move only through solid rock, but they do not move through any kind of liquid medium. So we see that if this is the earthquake epicenter, so earthquakes, usually we see that when it is originating, it actually doesn't originate at the surface, it originates little below the surface. Usually we see that the waves should travel in straight lines in this manner. But because of these are waves and because of refraction, we see that the waves will travel in a curved path. So in this way. So this is how my motion of the earthquake waves will take place. The curved path is also because of the heterogeneous densities present inside the earth, that is the rocks, the molten rocks. They don't have a uniform density, and also we are moving through different layers of rocks. We are moving through, that is again indirectly telling us about the layered form inside the earth. But that is the reason why the curves are not straight, but they are uh, the lines are not straight, but they are in curves, and they adopt curve path. So P waves in this case, we can see they are following a curved path, but we see that the P waves, they cannot move or they cannot flow through the liquid outer core part of the earth. So we see a very interesting shadow zone getting formed in case of where we see no P or no S waves in this part. So what happens is the P waves, they all get refracted in this way from the earthquake's epicenter. But though it can travel through liquid and through solid, it because it is getting refracted completely away, there is a part which is beyond the liquid core where we see that the P waves are not being able to enter. Similarly, this shadow zone, we also do not see S waves, and this is because S waves cannot travel through liquid. So very interestingly, we see that we have a shadow zone in the earth, and this shadow zone is because of the character of both the P and the S waves, stating that there is a layered feature inside the earth, and not everything is liquid as we have imagined. So certain parts of the earth, inside the earth, the molten magma is liquidy, and in some other cases it is solid, and in some other cases it is viscous. And it is rather very difficult to discuss these densities in such simple terms, because they have very different kinds of densities. So the P wave shadow zone, and of course also we have the S wave shadow zones. So S wave shadow zone is actually very large, because the outer core, which is actually liquid, because the earthquake waves cannot enter that, the entire core acts as a shadow area for the S waves. So we see that the shadow zones of both the P waves and the S waves, they correspond to each other, and they are dependent on the character or of the rock through which the earthquake waves are flowing. So it is telling us about the layer structures. Now I'll just briefly discuss a little bit about the two other types of waves, and much more different kinds of classifications of waves are being done. They are the L waves. So when we have an earthquake, and so if this is my earthquake, so we have the epicenter, which is really not at the uh, on the surface, and here we have the focal point, and from here we have the earthquake waves which are taking place. So we have the surface waves, and we have the waves which are the body waves. So that is why the destruction of the earthquakes is so intense, because we have two types of waves which are simultaneously acting: the surface waves as well as the interior of the earth, where through which the waves are also moving. So we have two types of surface waves. We have the L waves or the love waves, and this is named after a person. So love waves are a major type of surface waves having horizontal motion. And we have the Rayleigh waves. Again, this is named after a person. Rayleigh waves are another type of surface waves which travel through solids. So we will not concern ourselves too much on this, because this is not what we are looking into. We are looking into body waves, and we have to understand that better. So we will come into the concept of discontinuity, which we have talked in the previous chapter as well. So before we move on to the concept of discontinuity, I want to tell you that the earthquakes are measured by an instrument called seismometer. So seismologists use seismometer, and we have these seismographs. So you have these graphs which record the earthquakes. There are these stations, and there are multiple stations all over the world, and every day the earth is shaking and we are experiencing earthquakes. There is a scale which tells us about the magnitude and when we can call an earthquake as something which is very, very harmful. So we have talked a little bit about discontinuity, as I've already said in my previous video. So there are different kinds of material which form the Earth's crust, the Earth's interior. They have different kinds of material densities. So we have these transition zones between one layer and the other layer. So we have, say, this is one layer and this is my other layer. So we have this transition zone. We're calling this transition zone and not a transition line, because it the discontinuity does not occur as a line, rather it's a zone. It will occur in nature. Nothing occurs in straight lines, rather it's in zones. So one kind of rock density or one kind of rock type of layer will end and another will start and it will take place. So this layer of transition zone along which this change is taking place, they are called discontinuities, and different kinds of discontinuities have been discovered, and we have talked about the discontinuities in the previous chapter, which tells us that the earth has different layers. A lot of these discontinuities, again, that's very debatable, and geologists till date are debating about them. For example, the discontinuity between Sial and Sima is very much debatable. The kind of diagrams we draw in our geography books, we are used to see them. Uh, some geologists, a lot of geologists nowadays, they claim that it is not completely correct. So we really need to, in this case, when we are looking at geotectonics, we need to upgrade what we learn in school, and we need to bring about changes in our textbooks about these concepts, because with the development of technology, more and more knowledge is coming about these things, because we are drilling boreholes, we have computers, we have robots which go inside the earth, and a lot of information through indirect sources is being brought about. So I have very briefly tried to talk about the seismic evidences which talk about the interior of the earth. I hope this video was easy for you to understand. If you have doubts and if you have any questions, please feel free to leave it in the comment section so that I can look it up and answer whenever possible. And if you like this video, please uh, share it with your friends, leave a comment and subscribe to my channel. So, and please let me know what other kind of video you would like me to make, which part of geography is difficult for you. I'll try and make videos on those. So see you in the next video. So long, bye bye.